A very good morning to you all. Myself, Professor Ashok Bajantri, lecturer in Electronics and Telecommunication Engineering Department at Brahmdev Dada Mani Polytechnic, Solapur. So I welcome you all for the video lecture session on subject Electrical Circuit Network, unit number 1, that is Series AC Circuits. So first of all, let us see the basic component or the meaning of what actually is electrical circuit. So as you all know that you can define electrical circuit is nothing but a closed loop in which electrical current is expected to flow. So as per your Ohm's law, we know that current is expected to flow as a result of application of a suitable voltage source. And with respect to different types of AC sources are concerned, we have got two different types of electrical circuits. One is with respect to DC sources supplies are concerned, and second one is AC source supplies are concerned. So with respect to DC circuit, DC current flows, whereas with respect to AC circuit, AC current is expected to flow. Now maybe we can also classify depending upon the types of source with which the components are being connected, such as DC electrical current or DC electrical circuit and AC electric circuit. If you look into the nature of DC circuit and AC circuit, maybe they represent the two types of circuit. So which can be represented by the shown diagrams here. That is the first one. It is connected across a resistance component R across a DC voltage source called as battery source. Now in the second diagram, maybe you can see it is being connected across AC supply source across the same resistance R. Now in both the circuits, whenever any suitable voltage is being applied, as per Ohm's law, we know that current happens to flow across the load in order to complete the entire circuit. So which is the usual basic rule of any electrical circuits are concerned. Now again, when you look into the nature of a DC circuit and nature of AC circuit, we got to define what actually is a DC circuit. So DC circuit is one in which the magnitude of a voltage or current tries to remain constant irrespective of a variation of a time. Similarly, with respect to AC circuits are concerned, the magnitudes of voltage and the current varies continuously with respect to times are concerned. So in the first graph, maybe you can see that magnitude of voltage and the current remains at most constant. Whereas in the case of AC circuit, the magnitude of voltage, either the voltage or else the current, happens to vary continuously with respect to variation of a time. So in this graph, maybe when the time is varying continuously, the magnitude of voltage or the current is continuously varying. So which means that alternating supposed to be continuously varying, whereas DC supposed to be constant irrespective of a time is concerned. Now let us see the main content of your chapter number 1, that is meaning of series AC circuit. So series AC circuit is nothing but end-to-end connection in brief, what we can say. So any of the components with respect to electrical components such as resistance, inductance and the capacitance can be connected either in a series manner or else in parallel manner, depending upon the requirement of an electrical circuits are concerned. Now with respect to series AC circuits are concerned, each of a component, either resistance, either inductance or the capacitance, are connected in series with the AC supply source. This is the very basic definition of series AC circuit. Now depending on the type of components which when we connect, so there can be three different types of different combinations, which are RL series circuit, RC series circuit, then RL series circuit. So that is, if you connect resistance and inductance in series, then that forms RL series. Then if you connect R, that is resistance and capacitance in series, and that forms RC series circuit. Now if three of the components, that is resistance, inductance and capacitance, connected in series, then that forms RLC series circuit. Now basically first let us analyze the very basic circuit, that is RL series circuit. Now when we come to the analysis, it is expected that for a RL series circuit, it is estimated to find out what might be the value of current with respect to AC circuit when we connect RL series circuit. Then finally we will want to analyze what might be the amount of a power for a pure RL series circuits are concerned. So this is being analyzed in the further session. So initially consider an RL series circuit in which resistance R and which inductance L is connected in series across the supply voltage source of V. Now by the basic rule of Ohm's law, when you apply voltage, then that induces a current I. So now when the current flows across the resistance R and when the current flows across the inductance L, there assumes or there develops a drop due to the ohmic drop such as resistance and the inductance of a circuit are concerned. Now when we consider a pure resistance, there might be a drop that is due to resistance called as VR. Now similarly, there can also be a drop due to inductance called as VL. So this drop happens to be the resulting as and when the current flows within a series circuit. Now ultimately, if we can combine the drops due to resistance and due to the inductance, we can finally write an equation called as V will be equal to VR plus VL, which means that the total voltage applied across the AC circuit is equal to the algebraic sum of the drops in a series circuit. Now next is we have to represent this analysis by a phasor diagram called as phasor representation of RL series circuit. Now for this to represent, it is very much essential that we have to have the basic idea of the nature of voltage and current with respect to resistance is concerned, inductance are concerned and the capacitance effect are concerned. So we know that basically that if you consider a pure resistance, the nature of a voltage and the current will be in phase, which can be represented by the single diagram that is OA. So where we can see vector V and vector I both are in phase for a pure resistance. Now when we consider a pure inductance circuit, the nature of current is such that current lags the voltage by an angle 90 degree. Similarly, when we consider a pure capacitance circuit, current leads. So current is lead, which is shown in the above axis, that is with respect to 90 degree for a pure capacitance circuit. So these three things are very much essential when we are trying to draw phasor diagrams either for R, L or else for any of the series circuits are concerned. Now assuming RL series circuit, that is we know that if you consider pure resistance, voltage and current will be phase, and for inductance, current lags by an angle 90 degree. So this is shown here. So this OA represents the drop due to resistance. So this is represented by vector OA. Whereas inductance phasor diagram is represented by this vector across y-axis, which is lagging the voltage by an angle of pi in this circuit. Now, assuming the two vectors across x-axis and y-axis, I can find the resultant vector, which is the OB vector. So OB, by using a Pythagoras relation, we can find the magnitude of OB by this simple equation, that is where OB square is equal to OA square plus AB square. So where OB is the magnitude of V, where OA is the magnitude of VR and AB is the value of VL. So which is equal to V square equal to VR square plus VL square. Now if you want to calculate the basic voltage of the AC, then we can simplify this equation by writing V equal to square root IR plus IXL, where IR and IXL is the drop due to resistance and due to inductance component. Now finally, if we can take out current as a common, then we can write the equation I such that it is V divided by R square plus XL, where R square plus XL is called the impedance of AC circuit. Now this impedance is nothing but the total opposition force offered for a AC circuit. Now we are considering AC circuit, hence it is essential that impedance has to be considered. Wherein we can further modify this circuit such as I will be equal to V upon Z. So that is the total final equation for a current in this circuit. Thank you.